Hi, everybody. I hope everybody's doing well. Today, we're going to talk real quickly about levels of measurement and looking at variables and how these things are assessed. Generally, when you have variables, we use them to we attach numerical values to general concepts that we measure. So variables they take on two different properties. They either vary to some degree, right? Your level of like for a political party or an ice cream or whatever, and or they can be constant, right? Or they're fixed, like age. And as far as time is concerned, things are constant, right? Or gender. I mean, all political stuff aside, that stuff well, historically has been fixed to some degree. But without all the politics and all that stuff, we're just going to talk real quickly about the levels of measurement, how things are assessed, and why they're relevant to you. So these are the four things we're going to talk about: nominal, ordinal, interval, and ratio variables. And they go from simplest to most complex. So if you think about it that way, in a ratio, there's an absolute or a true zero involved. A nominal variable, it's the weakest level of measurement, and generally just they're qualitative assessments. Values that are placed on them are qualitative in nature. Hopefully this will make sense. Hopefully I'll make it make sense in a sec. But a nominal measure is a variable with attributes have only the characteristics of exhaustiveness and fully mutually exclusiveness. So mutually exclusive, what that means is two events cannot occur at the same time. So if you're flipping a quarter, it can either be heads or tails, right? You can't necessarily have heads and tails at the same time. So in nominal measures, so if you ask somebody, do you like, you know, your boss, and then they either give you a yes or no type of response to that, right? So it can't necessarily be yes no at the same time, not at a nominal level measure, but there's other levels of measure that can get towards that. So you can be mad at your boss at that period of time, so you put no, I don't like my boss, or you could have just got a raise, so yes, I like my boss, or whatever, right? So these two things can't occur at the same time. So tossing a quarter is a good one, rolling a dice, can't get a six and a three at the same time. So it can only be one thing at one particular time. So merely offer names or labels for characteristics. So um, differentiate subjects based on some classification, qualitative classification. So, for example, gender, right? Gender is a nominal variable. You can either be male or female. As I said before, I'm not going to get too political with it. Um, but historically, at least, either you can't be male and female at the same time. It's either one or the other, right? Or religious affiliation. It can't be Catholic and Jewish at the same time, right? It's either one or the other. Um, or Buddhist and Islamic. You can't necessarily be both at the same time. Or hair color. You can't have red hair and blonde hair, or red hair and brown hair at the same time. So, college major, you can't be a freshman and a senior at the same time. So, these are qualitative classifications to some degree, right? And as far as when they get put into a data set or to a statistical analysis, a lot of times you'll be placing a number next to these types of things. So if you have a category for religious affiliation, say you have Catholic and Baptist and Protestant and Jewish and whatever, right? You might put 1, 2, 3, 4, 5, 6, and then have a final category of other, which would be 7, right? That would make the category fully exhaustive, okay? Now, however you put numbers next to those religions doesn't necessarily matter, okay? Some people might say that, well, my religion is better than another, but at the end of the day, you can't necessarily rank order them to any degree, okay, without some subjective, opinionated uh, insertion into that. And hopefully that makes sense. So college major. So if we have college major within a data sheet, and we have freshmen, sophomores, juniors, and seniors, sometimes you put a 1 next to the freshman, 2 next to the sophomore, 3 next to the junior, and 4 next to the senior, right? It could also be done the opposite way. Is what I'm trying to make. Trying to say. So 4 could be assigned to a freshman, 3 to a sophomore, 2 to a junior, and 1 to a senior. It doesn't really matter. They're just placeholders there. So, and that's a nominal measure. So mutually exclusive. Those are the characteristics of those types of variables. So an ordinal is the next step. It's the next step in the measurement, level of measurement, in the hierarchy of measurement scales, I guess. So it's a level of measurement describing a variable whose attributes can be rank ordered along some dimension, either logically rank ordered. So enable the placement of objects into ranks, such as highest to lowest. You can do so with socioeconomic status from low, medium, high. Um, personal views, perceptions. I know everybody's seen these Likert scales or Likert scales. Strongly agree, neutral, disagree, strongly disagree. So this is more of a range. So sometimes, well, ideally you're going to get more range because the truth isn't necessarily yes or no type of response. Now I go back to the example I gave earlier. Do you like your boss? Yes or no? Or do you like your job? Yes or no? Well, the truth generally isn't usually a yes or no type of question. So it's more, the more distance you can get, the more likely it is to be true, if that makes sense. The more range, that's what ideally you want. So I agree I like my job, or I strongly agree, or I agree that I like my boss, or I strongly agree, or I disagree. I'm neutral or strongly disagree, right? It could be on some type of dimension like that. And that's most things for most, especially opinionated responses, right? So if you like the current government, or you like this political party, or you like the way police work within your jurisdiction, or whatever, okay? That's getting closer to reality, and that's generally what you're trying to get with when you're measuring something. What the reality is, right? How delinquent are you? How deviant are you? Delinquent all the time, sometimes never, whatever. Okay, or hopefully that makes sense. But the thing about ordinal measures, distances can't. That I want y'all to know, the distances between these can't be considered to be the same. Okay, they're not necessarily equal distances, because your idea of strongly agree versus agree, the distance between those two and what makes you check one or two within that box is different from my strongly agree to agree. Okay, whether it's your perception of this political party or boss or whatever, your opinion on ice cream, right? Or from your distance from disagree to strongly disagree is probably different from agree to strongly agree, or neutral to agree. Okay, and hopefully that makes sense to you, because these distances can't assume to be the same, and that can be problematic. Okay, so that's an ordinal measure. So things get rank ordered on some dimension, some degree. Okay, now interval level measure. Now, these variables whose attributes are rank ordered, similar to ordinal measure, which we just talked about, but the distances between are there are equal distances between. We can assess the distance between, okay? There is no true zero, though, in an interval level measure, and a zero is an arbitrary assignment. So let's say temperature is generally used in this type of example, okay? So a shift from 10 degrees Celsius to 20 degrees Celsius is the same 10 degrees as it would be from 40 to 50. That's 10 degrees. The interval is the same. It's the same 10 degrees to some degree, although it's at a different level, right? The thing here is 0 degrees Celsius is when water freezes. Now, if we look at Fahrenheit, water does freeze. Well, it freezes at 32 degrees in Fahrenheit, and 0 is basically arbitrarily assigned. And one could argue it's arbitrarily assigned here, just to equate to when water freezes. 0 could have been when it's 100 degrees out, and we could have been looking at negative, or we could have whatever. Okay, so it's arbitrarily assigned. Just the intervals on these metrics. Fahrenheit is a metric. Okay, a metric is a level of, it's its own metric. Okay, Celsius is its own metric. So if you hear me saying, like, look at metrics and all that type of stuff, this is what I'm talking about. Okay, because when you standardize things, you're taking it off its own independent metric and putting it on its own consistent one. Okay, and that's for a different type of discussion I won't get too much into, but that's what an interval measure is. Okay, the distances, the intervals are the same. The distances between the intervals are the same, and 0 is arbitrarily assigned. Okay, and hopefully that makes sense. Now, the final level of measurement is ratio. So, describes a variable with attributes that have all the qualities of nominal, ordinal, and interval measures. So, there's equal distances between the levels assessed. Just the one unique thing of a ratio, it has a true zero, and that's why I think a ratio with an O, a true zero, if you're having to memorize this, okay? So it has a true 0 point, so a fixed and meaningful 0 point. Examples could be age, money, weight, etc. So money, if you look in your bank account, you have $0. It's a true zero, right? And that means something. That you have no money. So, or if you look in there and you have a couple $100, then you're good, right? Or whatever. Age, if you're 0 years of age, you're not even born yet. And that's a true meaningful zero. If you have 0 kids, you have 100 kids, right? Or zero dogs, you have 100 dogs, or whatever. Weight could be the same thing. So, and theoretically, these things go on infinitely, okay? I know it's hard to see with age and weight, but this matters for when you're doing certain statistical procedures, the ratio level of measurement. Otherwise, you're violating the assumptions of the statistical procedure itself. I know we talked about correlation coefficients last time, and then you have to have ratio level of measurements when looking at it. When you're doing ordinary least squares or linear regression model, your dependent variable needs to be a continuous measure. It needs to be a ratio or perhaps an interval level measure. Some people violate the assumptions and do use an ordinal measure, but that's violating the statistical, the mathematic assumptions. So we're taking all these things in sociology and psychology or whatever and trying to attach it to mathematics essentially, and we violate the assumptions a lot of times. But you do need to have these. There's other procedures for having a no or yes type of or a nominal type of dependent variable. Okay, and hopefully that makes sense. So if you're looking at recidivism, either yes, they recidivated, or no, they didn't recidivate. You could do a logistic regression model or something like that. So that's it. That's basically it. It goes from nominal, ordinal, interval, and ratio. So nominal is the weakest. Attributes are only named. Ordinal attributes can be ranked ordered. Interval distances are meaningful. There's a meaningful distance between the two, not necessarily an ordinal. And a ratio is all these attributes, only there is a true zero involved. Okay, and hopefully this helps you guys along. So yeah, have a good one.